Thank you, Vincent. Love to see TDD on a stage, actually. Thank you. I'm here to tell you today talking about Webpack, but first about me. I'm Norbert. I work at a company called Xebia. I'm a full-stack JavaScript developer. I do Node and browser. Something that happened to me very recently, I became the maintainer of Storybook. Maybe people know about it. But I'm going to be talking about Webpack. But talking about any technology, really, we should be talking about the problem that it solves. So many people talk about technology and get tired about hearing new, like a very high churn of JavaScript tooling, frameworks. So I think if we start talking about the problems, the new things that we experience solve, we can gain more understanding about it. And we can keep this JavaScript fatigue hashtag low on the rankings on Twitter. So the problem Webpack solves is that web applications are really complex. There's lots of stuff that's happening and it comes together when building our app. So there's CSS, images, JavaScript, fonts, templates, data all being combined, pushed to the browser, and it needs to download those assets and parse them, etc. And it coming together in a very standard way, that's kind of, this image is supposed to be there, right? This font's supposed to be there, but how can you be sure these dependencies are not actually managed? So, yeah, these assets, images, fonts, styling, these are dependencies on our app, on our application. So that's one of the core philosophies of Webpack, is that everything is a module. Every reference to something that you use, it's a module, and it's a dependency. And if you look at your application like that, you create a graph. Your app, your entry, it needs like a database connector, it needs some styling, it needs some templates, all these things, all these files that you've got all over. They create a dependency graph. I say graph because most people think about dependencies like a tree. It's not a tree, because you can have a circular dependencies, but also libraries that get lots of dependencies on them. And one of the philosophies of Webpack is that it bundles all those things together and outputs into a few files. So it sort of looks like this. You've got lots of files all connected together. Webpack takes a certain point where it starts traversing this graph, and then it turns it into a few files. This sort of sounds similar to a lot of people doing what they do with Grunt or Gulp, but it's different in a way that you actually are creating this graph with every file. So doing a few pipelines with Gulp or Grunt, you have a pipeline for your CSS, you've got a pipeline for your templates, stuff in JavaScript, stuff like that. With Webpack, everything is connected. If they're not connected by a dependency, they're not going to be bundled with Webpack. Sure, you can do like bundling your JavaScript with Webpack and then doing your CSS on the side with something else. You can do that, but why? Webpack can do it all. So Webpack comes with a file that's usually called the Webpack config.js. This is, a lot of people are hating this file because it can grow very complex. But in its essence, it only needs two things: an entry point, and an output. Webpack on its own will be able to take a lot of JavaScript dependencies and bundle them together. So this configuration would look at a folder called source and then an index.js file, and then whatever dependencies it has, it will bundle them into one file, and it will place that file in a folder called dist, and the file will be named bundle.js. So let's talk about some concepts. Webpack needs an entry point. It can have multiple, so you can have multiple pipelines. For example, if you've got multiple apps, you can ask Webpack to bundle multiple apps in one go. You could do that. But there's also multiple reasons. But for simplicity's sake and time, let's assume there's going to be one entry point for your entire app. So Webpack needs this to bootstrap itself, to go and do things. It needs a start point of your graph. And then it will output these things into chunks. If you just do very basic thing, it will have one entry point, lots of dependencies, one output file. These output files are sort of the same as chunks. Chunks have a more complex definition. But for simplicity's sake, let's call a exit file a chunk. Webpack then has a definition of a loader. This is sort of a file transformation. You can ask Node to require anything. But if it's a file that is not a JavaScript file, Node will just throw an error. It will not understand the syntax. So what Webpack loaders allow you to do is require anything, and this loader will kick in and transform this file into something Node will understand. For example, you could load in an image, and you could require an image. And an image loader would transform this path of a image file into something you would want. It can be anything you want. It could be a hash of the content. It could be the URL. It could be, I don't know, anything. So if we could use if we were going to use loaders, one of the most common loader is called the Babel loader. And it will transpile a JavaScript file that is written in ES whatever to ES5 or ES whatever if you configure it that way. You know, whatever you've got Babel configured to do, this loader will do it. Plugins. So anything that a loader does not do, a plugin can do. Webpack has something that's called the compilation lifecycle. There are lots of steps. I'll dive into that a little bit later. So how do we configure a plugin? We tell Webpack that there's a plugin array, and this is a plain array. As you may have noticed, this Webpack config.js is a normal JavaScript file. So you can do lots of crazy stuff in this file. This is where most of the complexion comes from. If you're just starting out with Webpack, I suggest keeping it simple. Having multiple Webpack config files is not all that bad. Actually, for starters, it's the most easy setup. So back to plugins. This plugin will just register with Webpack and inject itself into the lifecycle. The order of this array matters, but it's not guaranteed the order in which the Webpack, the plugins are executed. I'll explain that a little bit later. So and then another concept that we should know is a target. So Webpack can target multiple platforms. Of course, we all know the web platform. So that would basically means a browser. But it also has a Node target, and it also has a web worker and an Electron. It has a few more, but they are rarely used, and I have never used them. So how would we tell Webpack that we want a specific target? We just have a property called target. By default, this is web, so it will by default bundle for browsers. If you can imagine that JavaScript that needs to be executed by Node, it looks a little bit different from what needs to be executed in a browser, right? So, examples. I've created a few very small micrographs, like a dependency chain. And what I want to look at with you is what Webpack actually does with this graph. How many of you have actually used Webpack and then looked at its output? Nice, actually, quite a lot of people. Nice, good to see. So I've got this index.js file, and I will tell Webpack that I want this file as its entry point. And as you can see, I load some modules, and then I log some things. That's all I'm doing. So when I ask Webpack to do, it will give me some console output. This is the default output that you will be getting, how long it took, what version of Webpack you're using, what chunk, what asset it generated, and which modules are in there. And then the way I'm running this, it also executes the code immediately in Node, so I can see it actually works. So here's just a quick glance through of the modules. They're just basically to have something that works, that's sort of a graph. It's not really interesting. What is interesting, though, is that I can do more exotic things. I can import CSS, I can import a zip file, a PNG file, a markdown file, and these things work. Provided you're using the right loaders. So here we go. So one of the loaders I'm using, it's called a file loader. It has detected that this is a zip file. It has no meaning in a browser context, so it just generates another file. So we can see that Webpack has now generated 2 files for me instead of 1. So when I actually import this thing, what I'm given is not the actual file, but a reference to the file. So this is really useful for stuff like images or files. In your code, you've got an actual requirement for another file somewhere, and in your code, you're actually given this reference to where it is. So how does this look? Damn it. I always get the keystroke wrong for removing the sidebar. So when people look at a Webpack output, they are faced with these weird, this large chunk, semi-large chunk of Webpack-specific code. What is in there is the dependency management and the dependency resolver that Webpack will need. It needs this especially in the browser, right? Because there is currently no module resolver in the browser. There's one in Node. So Webpack will sort of wrap around it a little bit. And it needs to, because of loaders. But we can have a look at what's in here. There's the Webpack require function definition. It will receive a module ID, and then it will, if the module has not been initialized yet, initialize the module, and then return the exports. if the module has already been initialized, it will just return the exports. This is conformant to this ES modules spec. A module should always be a singleton. It should never be initialized twice. What we can also see is our modules are all put in a large array. And this array has IDs or indexes. And this is what Webpack uses to reference a module. It's an index in this large array. It gives us quite a few comments, so we know what's going on. And something that I would love to see, I'm going to do the index one again. Here we go. Something that's quite new in Webpack 2 is something called tree shaking. Rollup made it very, very popular. It basically means that you can import a module, a very large one, like a collection of other modules, and Webpack will make sure that whatever is going to be in the output is as small as possible. We can see this in action already in this file, hopefully. Yep, there we go. There we go, I think. Sorry. Yes, here we go. So in one of my modules, I define an arrow function that returns a constant, but it's never used in our entry point, and nowhere else it's used. So in debug mode, which Webpack is in by default, it will still output these things, but it will add a comment there saying, this is unused. So it actually can detect that, and when you do a production build, it will remove it. So that's pretty cool. We can generate lots of smaller packages that way, ship less code to our clients, which make especially mobile phones a lot happier. Another thing that Webpack does really, really well is called code splitting. So especially when our apps get large, at some point we want to split our app into sections. We don't want to ship an entire app to a client because that client may be on a throttled network. So we want to ship as little as possible, or basically only the things that that page need. The way Webpack allows you to do this is by automatic code splitting. You can do manual code splitting, but I will not cover it. So the interesting bit, is automatic code splitting. I think that's really, really awesome. My editor is complaining that this thing is odd because this is very, very new. This is actually a stage 3 ECMAScript commission standard or proposal. It's called the declarative import. Imperative import. This is a declarative, and this is an imperative import. So this will hopefully eventually end up in browsers. Possibly it's going to be standardized next year. It works very much like static imports. You give it a module name, and it will resolve, except it will not resolve immediately, but it will resolve in a promise. So cool thing is we can use like promise all to chain all these things together. It's really awesome. But you're given the entire module, the module in its entirety, all the exports when the promise resolves. So what you can see is that I then, when this resolves, log it. I can show you this works if I type correctly. So there we go. Nothing changed. From a user's perspective, in Node, nothing changed. I can show you what is now different in in the output, because something definitely has changed, right? I can see there's this 0.index.js file. It's a Node module that Webpack will load asynchronously. And we can see this happening. It's always a little bit tricky to find it exactly. There it is. So Webpack will have this require ensure function. It's only there when you do code splitting, so Webpack itself will try and compress its own boilerplate at the top. So when you use code splitting, damn it, go away. Shh. Don't tweet at me now. When we're using Node as a target, which is what I'm using because it's very easy to demonstrate, it's fast, it will use the Node require. That's pretty smart. But if I were to change my target, which I can, to web, damn it, go away. Save this. And run it again. My terminal will complain, or actually Node will complain that there's window is not defined. It's because Webpack just generated something that's meant to run in a browser, and I'm trying to run it in Node, and that doesn't work. But I can show you, I could open my browser and see it, but it will only log some things, it's not interesting. But what is interesting is what this actually output, right? Because now Webpack needs to do something different. It cannot use Node's require, because Node's require does not exist in this context. It's only in Node. So what needs to happen, first of all, in the file that is going to be asynchronously loaded, this file just cannot export itself as a Node module could do. So it needs to inject itself into an existing Webpack installation, right? So it does that using a Webpack JSON-P function. You can rename this using some options in Webpack. And now Webpack needs to define this function somewhere. And then when this is actually called, it will install the modules that it has received. And we can also see that Webpack has generated a require ensure, once again, but this time its content is different. It will actually inject a script tag somewhere and load this file asynchronously. So this is actually how code splitting works in Webpack. Cool. So I talked about plugins a little bit before. I want to reiterate it and explain it a little bit more. So Webpack has this life cycle, and it basically means that there's a start to the compilation, and there's lots of steps that plugins can hook into, change some things, and then leave everything else to do its thing. So a plugin can do something really small, or it can do something really large, especially the optimization plugins like Uglify or Babily, or some analytics tools. They can be pretty complex because they now need to analyze this entire graph and everything that's been compressed, etc. But also there's some quite small plugins that will, for example, just call a callback function when Webpack is finished. This, for example, is what Webpack Dev Server is using. So it just needs to know, are there any new files? Do I need to swap them out? That's all it needs to know. Webpack itself, lots of the core code in Webpack is actually using its own lifecycle and are actually installed like plugins themselves. So this is pretty much all the lifecycle events that you can hook into. Stuff like run or watch run is called when Webpack just starts out. File is called when a file is ejected. You can read the documentation for Webpack online. Especially the documentation for Webpack 2 is very, very good. So writing your first Webpack plugin can be daunting, but this is basically all the code you need. It's a function, and it has an apply method. That's it. And as you can see, your apply method is past a compiler, and upon this compiler, you can register the lifecycles events. So what this plugin will do, it's really awesome. It will console log something when Webpack started. I think it's pretty great. So, using Webpack, 1 minute. Wow, dude. You can use Webpack in lots of ways. You can run it using an npm install. You can install it globally, but you shouldn't. You should install it locally and then use an npm script. I'm not going to make it in 1 minute. Can I have 4 or 5 more? 5, please. Webpack also has a Node API. So inside Node scripts, you can run Webpack. This is really powerful if you want to do custom builds, if you want to do multiple Webpacks at the same time, combine them together and generate something, and then kick off your web server, for example. This is really much, much more smarter than trying to start your server at the same time as your Webpack configuration, and then hopefully eventually they will be successful, right? Lots of people are doing it this way. You can actually start using the Node API. It's much, much better. It's cool. You can also run Webpack as a sub-process. I tend to use this a lot. It's really powerful. So Webpack 2. What's changed? Migrating, super, super easy. There's changes to how the Webpack configuration is structured, but it's not really that drastic. What's mostly has changed, though, is loaders and plugins APIs. So if you're a plugin writer, stuff has changed, but most of the plugins and loaders right now have upgraded. They are compatible with Webpack 2, and it should be a breeze. So Resolve has changed. I recommend you never use Resolve, but depend on how Resolve in Node works normally. Loaders has been renamed to Rules. This really, really quirky syntax of defining multiple loaders on the same file has been changed into an array. Finally, unfortunately, it's in the wrong order. Still. So Module.loaders can now no longer use a shorthand name. You should always define Babel-loader, whatever -loader. If you don't, it's really hard to figure out for Webpack exactly what you want, right? So loaders now have a property called options. You should never, ever, ever anymore use custom properties on your Webpack config. If you do, Webpack will complain in your face and will not run. Preloaders has been removed. ExtractTextPlugin has been refactored. This is the major, major point I faced when upgrading to Webpack 2. Actually, it's not all that hard, eventually. So Uglify.js plugin has been changed a bit. Another few plugins have been made redundant, so we no longer need them. Code splitting has been refactored a bit, and it has now been conforming to the standard, or proposal standard. You should now stop using a full expression in a require statement. It's really, really bad because Webpack now can no longer figure out what you might require. Basically, if you do the above statement, it will need to include everything in your bundle, everything it can find, every file, because this could resolve to anything. It's JavaScript, anything goes. But what is supported is passing in a partial expression, because now what Webpack needs to inject into its bundle is more fine-grained, right? It's only the files that are actually in this path. You should stop transpiling ES modules. If you're using Webpack 2, stop transpiling ES modules. You can do it like this, but much better is actually using Babel and a plugin preset. So stop using ES 2015 preset. In conclusion, Webpack, Babel, NPM, they love each other. It's a happy marriage, 3 ways, but yeah. Yeah. So my conclusions, Webpack is awesome. It's not magical, as lots of people seem to think. Its configuration file is not all that bad. It has a fantastic ecosystem. You can use it in many ways, and upgrading to Webpack 2 is easy. That's it. Thank you.